Mine was good. It was nice. It rained a little bit Saturday, but anything you do fun, Rachel? It was an outdoor kind of weekend. It was nice and warm. On Sunday. Oh yeah. Yeah, that's right. Yeah. You got uh that going there. Good. Yeah, that's a lot of fun. Good job, guys. Thanks for coming in. And your teachers are back of all sorts. Everybody should be back now. So you should be able to get uh, that happens to me too. I sing in the choir and it does. I go on and on and on. You know what? If you have to break it, they tell me chewing gum helps. Chewing gum helps if you have to break the if you want what they call an earworm, right? Break the earworm. So you see week 14 here. Where are we? Week 14. So we are week 14. Oh my gosh. And it is so we've got 4 weeks left. We have 3 weeks left, and we'll have the universe on week 14, week 18, and that'll be all bonus. So you have 3 weeks of assignments left, right? So let's get focused here, right? Let's get focused. I'm going to show you where is that? Guess what this is. Okay, let's do a guess what this is. Share. And let's see if we can let's do a poll here. Hide this. We'll take the poll, start a poll. Let's guess. So this is just kind of a focusing assignment. See if you can guess what this picture is. And I will share this with you. This ABC or no, not D, ABC. All right, anonymous poll here. Start. All right, so here is the see what this is. Some picture will reveal to you what it is. All right, what do you think? Is it a car, a farm, or a garden? Some of you think it's a car. All right, one person thinks it's a farm. I didn't give you much opportunity here. Let's see. Most of you guys thought it was a car. See what happens. Yep, it is a car. All right, so let's start another one here. This is guess number 2. Start. All right, what do you think this one is? Focusing here. All right, what do you think? Dark, park, or party? 6 of you say it's park. Excellent. Yep. How about this next one here? Let's go. Next one. This is start a poll. This is number 3. How about this one? You guys got it? It is a spark, a yard, or a dark. These are all AR words, by the way. So, all right. This one is a little tougher. A little tougher. All right. Got 3 people say letter C. Okay. Excellent. Okay. Thanks for focusing on this, ladies and gentlemen. This, again, let me escape here. Escape. All right. So we are talking about wave interactions today. So just to let you know, if you haven't done week 13 quiz, that's due today. Week 13 assignment 1 and 2 was due. I graded that this morning. Still had about 117 people that didn't do it. So let's try and get in there, get that done. So let me go to this slideshow here. So what we're learning about is light and sound waves and how they interact with each other. Okay, light and sound is part of our communication and things you can see, and we using technology today to make certain things happen that we're just understanding. So what they call metamaterials alter light and sound waves. So metamaterials might be some strange looking material that is on a pillar in a cathedral or a church, where that lets the sound pass around or the light pass around, so that people getting the best view. And usually you're sitting next to a pillar does not let you see or hear very well, but they are trying to make some materials that help reflect or bounce the light around or bounce the sound around. Okay, that's a new tech. It's new within the last 10 years, called metamaterials, and they use them. They're using them to create places or spaces so that islands that are susceptible to tsunamis, and they're looking at ways to make the waves go around the island rather than go over the top of the island. So, especially in this in our time frame where we have global warming and sea levels rising, it's very easy for an island that's not only a few feet off the ground, or I should say at sea level. If they don't have really high spots, they can certainly be swept away. So we talk about those in general terms today. All right, and there's a lot of things in the module that you can play around with. Right, play around with the FET light energy, and we have some wave interferences that we'll be talking about. So the first part of this is we're going to be talking about optics, right? And optics is how light interacts with matter, the type of matter that determines how the light passes through. And they are coming up with really interesting materials that they combined even aluminum and glass together and make them transparent, but also very strong, very thin compared to, like, bulletproof glass is like 6 inches thick. If you've ever been into a bank where they have glass like that, they are coming up with materials that are half that thick and can keep a bullet from passing through it. So those are some interesting things. It's a shame that we have to have bulletproof glass, but that's unfortunately what our environment is. Right, so let's first take a look at this idea of transparent. Trans means to move through. Um, so you're moving through your parent. so matter can pass through a piece of glass or the air. The medium allows all light pass through, and you easily see that. Now, there are different ways that light transfers or moves through the air, and we'll be talking about that as well. And then light passes through glasses, and my glasses have a certain index to them, what they call index of refraction, that makes it so I can see clearly. I'm what do you call nearsighted, so I can only see near, and that's why I have my glasses on. I had them since I was fourth grade. Wow, long time. So let's look at this idea of opaque matter that does not allow anything to pass through, like metal, wood, stone. So objects that they either absorb or reflect the light instead of allowing it to pass through. So you can get a silvered piece of glass that will reflect the light back and not pass through. So we have different words for that. So we say that opaque. I think of paint when I think of opaque. I'm putting paint on something. So it doesn't allow things to pass through it. Then we have shadows, right? We can use an opaque object will produce a shadow, and the light is obstructed by or blocked, right? And you get these different shadow patterns. Hey, Carmen. Then we have this idea of translucent. So trans means to move through. So, but lucent means the light is scattered, right? So we have these paper Chinese lanterns here, and the light does you can see the light through, but you can barely see the bulb in there. So some of the light is being transferred, and we have some are bounced off. So we can see the lantern, we can see the color, we can see the light coming from it that's probably dim. It's nice for yard parties and so forth, having these lanterns for celebration. Now you might have a translucent piece of material on your bathroom window. So if you have a bathroom window, you want the privacy, you can have that where the light is scattered. You might see from the outside, you might see a shadow of the image, but you don't see very clearly. But the light does come in, and it keeps you from having to have lights on all the time. I have a bathroom that has no windows in it, and so I have to use lights in that all the time. So let's go over here. Let's try this. So what we just talked about to try to keep you focused. All right. Right. So let's do this. Try to keep you focused. Let's see what you remember about shadows, translucent, and transparent. Matter allows all the light to pass through it. Which one of those is matter that allows all the light to pass through? What do we got? Thanks, Chloe. Thanks, Kendrick. Thanks, Dylan. And Gabby, thank you. About you, Rachel, Kylie, and Brad, you guys in there? All right. All right. So we got 7 out of 8. That's pretty good. And most of you guys said letter C, which is transparent. So if you don't know those things, if you haven't heard those things, might be a good idea to write these down as you're going on. Try to write those down, what the definitions are. All right. So let's go to this next one here. All right. So I'm going to put back to the slide presentation here. And let's go here. All right. Share this again. Okay. All right. So we said transparent. Right, so let's look at some light behaviors some more. Optics, again, is, you can get yourself involved in making microscopes, optics, you're making camera lenses, optics, making telescopes. They do have reflection not microscopes, telescopes, reflection telescopes, refraction telescopes. In my hometown of Adrian, they have a company called New Wave that makes some really exquisite telescopes, and they take great pictures of the sky. They're about $30,000 is the lowest price, and most, which is nice because the college or university can buy one and do some work and display that to the public without spending hundreds of thousands of dollars. So we have this idea of reflection, refraction, diffraction, and interference are what we're going to be talking about today. So anybody been to the Chicago Art Museum and gone across the street to see the Bean? The Bean is this big piece, a sculpture piece. It's all um, looks like all mirrors, but it looks like a kidney bean. Anybody gone to Chicago to see that? Anybody seen that? Anybody been to Chicago? Let me ask that question. Anybody been to Chicago? Nope. Too far away for you guys. Rachel's been there. Okay. So it's right by the art museum. I'd recommend going to see. It's just a beautiful, shiny structure. All right, and it's got mirrors attached to it. So it's and they're thin metal mirrors, and you can get a picture of yourself. It's just really, but mirrors, light reflexes or bounces off. Well, we talked about transparent, where we're going through. Here we're reflecting, and that's bouncing off, right? Bouncing off. Right. And if you take a physics class, you will learn more about the reflection, and then you'll be measuring these things. So they're what they call the angle of incidence. Incidence means the light going in and to bounce off on the surface. And then the angle of reflection. All right. So you get an angle of incidence and angle of reflection are the same. They give this line out down the middle, which we call the normal line, which is also what we used when we were talking about forces. Okay, so you'll learn more about that, but what we're basically interested in is the word reflection and what it means. So change in the wave's direction bounces off the surface of different medium. All right, so there you can see a mirror, incident ray, reflected ray, and again, if you get into the science of images or optics, if you take an optics class, you'll have to do some measurements here. All right, so this is a non-example, and if you've ever seen this is a glass of water and this looks like a paintbrush, broken paintbrush. That's not reflection. They give that another word for that. And we'll talk about that in a couple other slides. So there's different types of reflection. There's specular reflection, which is spectacular. And I think of spectacular because, you get to see an image, so the specular reflection bounces on regular spots, and they are reflected back at the same angle, right? So uniform, erect, and orderly and again, example of mirror. I'm not sure what a funhouse mirror would look like, where you look shorter or taller or fatter or skinnier. Um, they may not have the same, they don't have the same reflection patterns. They may be at different or odd angles, but used to love to go to those at the fair, have all those mirrors in there. Seems like you get lost. So here is specular, but then we have what we call diffuse reflection, where light rays hit a rough object. They still reflect, but not at the angle, not all at the same angle. So see here, these are reflecting at the same angles back to you and then making an image. Diffuse, they are rough surface and reflect not in a uniform pattern, but cannot produce an image. So here's an image. See an apple on this side. I draw a little apple. Oops, that's a laser pen. Not a pen, turn on the pen. So if I have an apple here, my reflection is going to be an apple over here. Here we will not see that image. You'll see some reflection of light, but not anything where it forms an image. Okay, now we have refraction, right? So it's like you have light being bent because the speed, we're using different mediums. So here is air. right? Air. And then we see the image perfectly here. But when it goes into the water, it refracts and it bends it. Now, the reason that this is good for us is because I have poor eyesight, so I have to have glasses that refract it so I can see. So refraction is helpful for people wearing glasses. Those are important for us to see. And they also, if you have laser surgery, they for your eyes, they'll make the refraction because your eye bends the light to go down back to you, the back to your optic nerve and the back of your eyeball. And if it doesn't focus just at the right point, it'll be out of focus. Now we can also do that for your eyes, and then you can don't have to wear glasses. Now, unfortunately, they are still trying to figure out how to make it so you're, as you get older, when you turn 40, the lens in your eye, so there's the cornea that we can shape so that when you're young that you can see without glasses, but the lens inside starts to get hard and doesn't flex as much to focus. And eventually, after 40, you need to get glasses. But they are working on making material to go inside your eye so that when you get to be 40, you can see things up close or far away without having to have those cheaters, what they call, my brother calls them cheaters, where you're having to wear glasses, even though you didn't have to wear glasses all your life. So refraction is important for eyeglasses. It bends the light so we can see using those glasses. And you've probably noticed it when you've put something in the glass of water. So now there is another type of refraction, and I have prisms all over my house so that I can have all these nice colors, rainbows. But the special kind of refraction is using a triangular object called a prism, and it uses what this is called dispersion. Dispersion gives you those colored bands here. So these are the colored bands, and because different colors refract differently, this causes white light to separate in these colors. Okay, white light has all the colors in them, but when we use that was how we figured out that white light had all these colors in them, is because of glass like this. Hey, Adrian, how are you? Who else came in today? John, good to see you, John. I didn't say hello to you earlier. Good to see you. So we have a dispersion, which is a special type of refraction. All right, so refraction talks about the bending of light, right? It's not reflection because the speed of the wave changes as it goes through medium, and a medium, remember, is like a gas, a liquid, and a solid. So that we have gases and we have liquids here that are transparent, and solid, we have glass as well. And we can change the refraction on glass so we can have better eyesight. So here is how many people have seen a mirage before? How many people have seen a mirage on the highway, especially in the summertime? Looks like what? What does it look like when you look at it? Thanks, Gabby. Thanks, Rachel. Yeah, it looks like water, doesn't it? It looks like water. Yeah, and you get up there, you might have been young and say, hey, there's water coming up. And then when you get up there, it's still dry. So you probably ask your parents what's happened there. And here is how this works. Let me turn this off. Pen off, and let's see this.
On a hot day, you might come across a mirage. It looks like a puddle of water reflecting light. But that isn't a puddle of water. And light isn't actually bouncing off the road at all. So what's going on here? On a hot day, the ground absorbs quite a bit of heat and makes it so the air gradually gets hotter closer towards the road. And hot air is thinner, so the air gradually gets thinner towards the road. But here's the weird part. light travels faster in thinner air, so the light actually speeds up the lower it gets. Kind of like driving a car from sand to asphalt. The car speeds up. But look, the car also changes direction. As soon as that first wheel reaches the asphalt, it speeds up and swings the car around, changing its direction. And light does the same thing, except this time the light gradually changes direction as it moves through progressively thinner air. And at some point, the light bends so much that it beams back upwards into your eyes. But our brains just assume that the light came to us in a straight line, so it looks like it's reflecting off the road. On a hot day, you might come across...
All right, so splitting of light into component colors called dispersion. It's a special type of refraction. All right, so let's do this question here. All right. All right, so splitting light into colors, is that spectral reflection, diffuse reflection, refraction, or dispersion? Thanks, Dylan. Thanks, Chloe. Thanks, Adriana. Thanks, Dalton. Thanks for getting in there. Thanks, Kylie. And all right, we've got Carmen and Rachel, everybody except for Kendrick and Bradley. Okay. All right, so almost everybody here. And this is dispersion. Okay, so, right. Now, the one last thing we're going to talk about here before we go is interference. Okay, so let me show you this from this point of view from, and then we'll pick this up tomorrow. Okay, because we have an awful lot of things that we've been talking about. So interference is when two waves interfere or superimpose over themselves and alters the intensity of the light. So there's what they call constructive interference, and there's some really good PhET online labs for this, and those are part of your week 14. Light waves can constructively interfere or destructively interfere. The white ones are constructive and the black ones are destructive. And basically what it's showing is that the waves are getting bigger or smaller when they interfere with each other. So here, this guy is creating, he's got two tennis balls on some, and he's making two waves. And what ended up happening here, if you see where we're looking at, right? The waves are in here. Over time, you can see right here these bands. Let me see that come up again. So when these waves interfere, these bands are what they call, they're low. Okay, so they're lower than normal. They're almost like at that part, if you were on the boat and you were in that area, it would be very calm. And here, the waves are constructive. They're doubled in size. They're constructively adding on to the wave. Now, and that's in between these parts here, constructive interference and destructive interference. And we'll be talking more about that tomorrow. So interference explains how the bubbles have bright and dark spots on them. Waves that interfere and constructively interfere have the bright spots, and then waves that destructively interfere have the dark spots. Okay, so let's do this here a second. Okay, so I'm going to share this with you guys. Publish, share. Okay, so let's work on this a little bit together here. I'm going to give you this link here. Let me close this out. All right, let's practice on this a little bit. Okay, and see how this works for you. Okay. right, tell me when you're in there and we can practice. I'll close this off a